Okay, this problem is really interesting problem. So this is related to the concept of solubility. So this question relates to the concept of solubility. The question says basically there are two equilibria that is given to you. So first let me write first equilibria, ZnOH whole twice. This is a solid and this can dissociate into Zn2 plus 2OH minus. This is aqueous, of course this is also aqueous, and Ksp is given for this reaction. So Ksp is given. I will give you the value also. We have another reaction that is given, that is ZnOH whole twice plus 2OH minus. This is solid, this is aqueous, and this forms ZnOH whole 4. And this formation constant is given to you for this reaction, Kf. Question says calculate the concentration of OH minus. What is the concentration of OH minus for which solubility is minimum? For solubility of ZnOH whole twice is minimum. You have to also find the solubility. So you have to also find solubility of. So two things you have to find out. What is the concentration of OH minus and what is the solubility also. So let us copy this one, and Ksp is given to you. So Ksp value is 1.2 into 10 to the power minus 17, and Kf value is that is also given, that is 0.12. If you have copied this one, then we'll discuss. Let us copy fast. This is a quite interesting problem. You see, in the class we have said two things. Solubility of any compound can be affected by either complex ion formation, that is a 1, or it can be deviated by some common ion. Like if you have AgCl, solubility of AgCl can be affected if you put initially some Cl minus, that is a case of common ion. Initially if you put some Ag plus, that is also again a case of common ion. So in one case is a case of common cation, in another case is a case of common anion, of course. So in both cases solubility will decrease. So if I want to decrease the solubility, I can use the concept of common ion. But if I want to increase the solubility, I can use the concept of complex ion formation. I can put a something, cation or an ion, that basically reacts with the ion that is formed after the reaction. So let us try to use these concepts in this reaction. So we have, so ZnOH is a solid. This can dissolve into the solution. So solubility of ZnOH whole twice, the dissolution, this gives Zn2 plus OH minus, and Ksp is given to. So this is simple solubility equilibria. Now solubility of this can be affected by complex ion formation also. So ZnOH whole twice, so there are some OH minus is coming. So if this dissolves, some OH minus comes. But now this OH minus that comes can further react with the ZnOH whole twice. So some ZnOH whole twice, this gives OH minus. This OH minus that is coming can again react with ZnOH whole twice. This means finally we will get ZnOH whole 4, and this will be basically 2 minus, because charge has to be conserved. So you see, the OH minus that is coming can further react. Now in the solution itself, initially I have OH minus, so I can control the concentration of OH minus. So let us say I have a solution. This solution initially also contains some OH minus. So now I know the concentration of OH minus. And now if I put ZnOH whole twice, and then So ZnOH whole twice will dissolve. Now the concentration of OH minus is known to you. Basically this is fixed. So solubility, this can be expressed in terms of OH minus. You try to see what we want to say, that there are some OH minus that is initially present in the mixture. And this, what should be this OH minus? Now I can change this OH minus. This is a variable. So this OH minus, that is, I am putting from out source, that is variable. So if I take less OH minus, I can have different solubility. If I have excess OH minus, I will have a different solubility, because you see, solubility of this depends upon OH minus. If I have excess OH minus, solubility will be less. But if you see, if I have excess OH minus, this side solubility will be more. So you see, there are two factors. If I control OH minus, if I take OH minus excess, this reaction will go this side. So using this solubility, because this is dissolved by two reactions. So you see what is happening. ZnOH whole twice. Let me write here. So ZnOH whole twice. This is going to dissolve by two reactions. In one reaction this forms Zn2 plus. In another reaction it forms ZnOH whole 4 2 minus. Now if I increase the concentration of OH minus, this reaction decreases. So you see, if I increase the concentration of OH minus, solubility that is coming from this reaction decreases, because this reaction will go this side. So if I increase the OH minus, if I increase the concentration of OH minus, solubility due to this reaction, let us say solubility due to this reaction is S1, or you can say X. So let us say solubility due to this reaction is X. This decreases. Now what about this reaction? If I increase the concentration of OH minus, this will react, so this reaction goes this side. So solubility of this compound due to this reaction, if I increase the OH minus, increases. So I can say, if I increase the OH minus, solubility due to this reaction is by also increases. Are you getting or not? So you see, if I increase the OH minus, X decreases, but by increases. This means I can always have a situation in which I can control the OH minus so that I will have maximum solubility, because this one factor is increasing the solubility, another factor will decreasing the solubility. So I will have a situation when in that case basically I will have a minimum solubility or maximum solubility depending upon the condition. Basically we will see the mathematics. So I can have these two opposing factors. So I will have a situation when I will have a critical situation. At that point of time I will either have a minimum solubility or I will have a maximum solubility. So let us try to do this problem. Now the idea is very simple. Now one can do this problem now in an easy manner. So let us try to do this one. So any idea you have? So let me do this one for you. So you have two reactions. First reaction you have ZnOH whole twice. This gives me Zn2 plus 2OH minus. So this reaction you have, and Ksp is given to you. So let us say from this is a solid. From this reaction the Zn2 plus that is coming is X. So I can write X into OH minus raised to the power 2 is equals to Ksp. So what is the value of X? X is nothing but Ksp divided by OH minus raised to the power 2. So this is my one equation. I can write the second equation, that is ZnOH whole twice. This is a solid plus 2OH minus, that is basically aqueous. This reaction you have, and this gives ZnOH whole 4 2 minus, this is Kf, and this is again aqueous. So if I see in this reaction, so this solubility is by, so I can write by divided by OH minus raised to the power 2, this is equals to Kf. So from here I can write by is equals to Kf OH minus raised to the power 2. So this is my equation number 2. So what is the total solubility? I will go slightly fast now. Every concept is easy. So total solubility So total solubility is x plus y. Are you getting? So what is the value of x? You see in the first part we have said x is Ksp by OH minus whole square. So this is Ksp divided by OH minus raised to the power 2, and y is nothing but Kf OH minus raised to the power 2. So this is my solubility. I want this solubility to be minimum. Are you getting? And this is a function of OH minus. Solubility is a function of OH minus. I want solubility to be minimum. This means I have to differentiate with respect to OH minus and then put it equals to 0. Are you getting or not? If you have confusion, so let us put OH minus as another variable. Let us say for this time, for differentiation, let us put OH minus as x. So just for simplicity, let us put OH minus is x for only for differentiation. So I can say S is equals to Ksp divided by x square plus Kf into x square. Now I need to differentiate, so ds by dx. This is equals to x square, differentiation of 1 by x square is minus 2 Ksp by x cube, and differentiation of this is 2 times Kfx, and this is equals to 0. So we will have 2 Ksp by x cube. This is equals to 2 Kf into x. So we will have so if I solve this equation, we will have Ksp so we will have Ksp by Kf, and that is equals to x4. So x will be basically Ksp by Kf 4th root, so 1 by 4. So this is the concentration of OH minus. X is nothing but OH minus. Now you can solve for x. So x is Ksp is given to you. You see your copy, you will find this is 1.2 into 10 to the power minus 7 minus 17 divided by, and this is 0.12 raised to the power 1 by 4. So I can solve this one. So let us solve this one. What is the value of x that is coming? So this is simple in this case. So this is 10 to the power minus 16 to the power 1 by 4. So this is 10 to the power minus 4. So concentration of OH minus is simply 10 to the power minus 4. What is the solubility S? That I can write. So this is Ksp by x square. That is 10 to the power minus 4 raised to the power 2 plus Kf by Kfx square. Kf is 0.12. So let us say 10 to the power minus 4 raised to the power 2. And Ksp is 1.2 into 10 to the power minus 17. 10 to the power minus 17 divided by 10 to the power minus 8. Here you have. Plus Kf is 0.12 into 10 to the power minus 8. So I solve this one. So what this value comes out to be? So this is 1.2 10 to the power minus 7. So 9 10 to the power minus 9 plus 0.12 into 10 to the power minus 8. So the minimum solubility will have, so 0.24 into 10 to the power minus 8. So this is the minimum solubility that is possible in this case. I can also write the same thing using 2.4 into 10 to the power minus 9. So this is in terms of molarity, because Ksp and K both are in terms of molarity. So this is the minimum solubility. You see, in this question is basically a really important question. You see, in this case there are two driving forces. One force that increases the concentration or increases the solubility of ZnOH twice if I decrease the concentration of OH minus. But at the same time reaction 2 goes down. That is, the one factor increases the solubility, another factor decreases the solubility. These two factors are opposing to each other, and that's why we have a minimum solubility. Basically you can also prove this is a minimum, this is not a maximum. So this you can do. You have ds by dt, ds by dx. If you differentiate 2 times, and then you can prove this is a greater than 0. So what is the condition for minima? That is d2s by dx square should be greater than 0. That is the condition formula. That is of course here we have. So if you differentiate 1 by x cube, so this is minus, and differentiation of x cube is 3x 1 by x minus x4, so this will be plus. You can verify yourself. And this is the differentiation of this is 1 plus, so this term is plus. After differentiation this term is plus, so d2x by dx square is greater than 0. So this means this solubility is minimum. This can also be proven by this expression. You see, are you getting or not? If you are not getting, I can prove yourself, prove for yourself, or I can prove. So let us prove. 1 minute I will take, not more time. So let us say I will have something like this. So I can prove here. So d2s by dx square, this is equals to, so this is x cube, differentiation of x cube is minus, and minus of minus, so 3 into 6 ksp divided by x4. This we have to know. I cannot do anything. This is a complete mathematics. And this is 2kf. Now this is positive. This term is also positive. So this is greater than 0. So this is a condition of minimum. Are you getting? So this is a quite interesting problem. Let us go for the next problem. I think you have copied this one.